proportional versus non-proportional relationships. If the ratio or rates of two quantities are equal, then the quantities are proportional. If the ratio or rates of two quantities are not equal, then the quantities are non-proportional. Here is an example. So we have the number of items sold and then the amount raised. Okay, so if I sold 5 items, I have $30. If I sold 10 items, I have $60. So first thing we need to do is we need to go ahead and we want to put the money over item. We want to figure out, is the cost of the item the same if I sell 5, 10, 15, or 20, okay? So go ahead and put 30 over 5. So we can work that out. 5 goes into 30 6 times. So that's 6 an item. Now moving on to the next one. If I sell $60 for 10 items, I can go ahead and 10 goes into 60 6 times, so $6 an item here. About 15 and 90. So 15 and 90, I can go ahead and put $90 over 15. 15 goes into 90 6 times. That is also $6 an item. And last but not least, figured out for 20 items and $120. So if $120 on 20 items, 20 goes into 120 6 times. That is also $6 an item. So if we were trying to figure out, is this table proportional or not? The answer is yes, it is proportional. And it is at a rate, a unit rate of $6 an item. Our next example is comparing it. So we have the hours of snow and total accumulation. So is it proportional? Did the snow fall at the same amount or the same rate per hour? That's what we need to go ahead and figure out. So figure out yes, it's proportional or no, it's not. So first thing, we're going to look at hours of snow. So we want it in hours of snow for our unit rate. So we want total accumulation over hours of snow. Okay, because we want to find out for every hour, did it accumulate at the same rate? So right here, the first one, 3.5 over 1. Well, I don't need to do any division there because any number can be a fraction over 1. So this one is at 3.5 accumulations per hour. Now on to the second one. So in 6 accumulation in 2 hours. Well, 2 goes into 6 3 times, so that is an accumulation rate of 3 an hour. It's an each. Okay, moving on to the next one. Well, at this point already, I can already tell it is not proportional. So if one of them isn't proportional, it doesn't matter if the rest of these will match, because sometimes they will do that to you, where all of them will match except one. That is the trick that they like to use. However, if these two right here don't match, we already know the answer is going to be no. They are not proportional. Okay, so using this example, I want to show you another way to go ahead and see if something is proportional or not. Okay, if we have, so using this example, another way that we could do this, we have 1 over 3.5, right? So we have hours of snow over total accumulation. Always make a key. Okay, the key is very important. About 60% of your tests at the end of the year can be done using proportions. So if we set them up properly, it's going to be very easy to go ahead and get these problems done and understand what we're looking for here. So just always make a key. It is a good tip to help you out. But so I have the first option right here, right? So here is this is what I wrote here. I have 1 over 3.5 equals the second group, so 2 over 6. So pay attention, I have hours of snow, to hours of snow, both my numerators, and then total accumulation here and here. So that's this one and that's this one. So another easy way to solve a proportion, I don't know if you guys remember it, but it is cross multiplying and dividing. Okay, so I'm going to, come on, get my pen to work. Okay, 1 cross multiply, so cross here and cross here. Don't know, I think I've heard that called a butterfly before, but what that means is 1 times 6 is equal to 2 times 3.5. 1 times 6, that'll give me 6 equals 2 times 3.5 gives me 7. 6 is not equal to 7, so that information is not proportional. Okay, now completing the table. So we have a table here, right? And we know that a car travels 35 miles per hour. So we need to figure out in 1 hour, how far does it go? Well, it tells us it goes 35 miles per hour. So in 1 hour, it would go 35 miles. Okay, well, if it goes 35 miles an hour, and in 1 hour it goes 35 miles, how far can it go in 2 hours? Well, since I know the unit rate, I know for every hour it goes 35 miles, I just need to take however many hours and times it by 35. So 35 times 2 will give me 70. So in 2 hours, the car goes 70 miles. Well, if that's the case, and I just times it, in order to figure out how far the car is going to go in 7 hours, it's going to go 245 miles. I just times it by the unit rate. And how far will the car go in 10 hours? The car's going to go 350 because 10 times 35 is 350. So that is how we complete the table. And this would be proportional because the unit rate is the same. So if I divided 1 by 35, okay, so if I do 35 over 1, it is 35 miles an hour. Okay, well, this one, 70 divided by 2 is 35 miles an hour. 245 divided by 7 is 35 miles an hour. And 350 divided by 10 is 35 miles an hour. So the unit rate is the same, and that is proportional.